All right. Good to meet you guys. My name is Josh Newroth. I work for a company called Anker. We're going to talk about nodes today. So I want to do a quick audience poll here. How many of you have ran a Solana node yourself? Okay, good amount, good. And how many of you are just curious, like how nodes run, some of the challenges, maybe you don't know that much? Awesome, okay, great. And then I'm just curious, how many of you provide node service as like a commercial offering? We got a few of those guys. Awesome, okay, great. So we're gonna talk about optimizing nodes here and what really peak performance looks like in our experience. So let me give you a little background on Anker. We're an EVM-based RPC provider. Since then, we've expanded into liquid staking. We were first to market on Ethereum liquid staking, compete with Lido on that. We do gaming SDKs, a lot of developer tools. And last year, we had a lot of clients coming to us in 2021 asking us to support Solana. And so we started this journey of figuring out what it would take to build on Solana at scale and offer that to our developers. So we begun to do that, but it wasn't an easy journey. So we have an RPC for Solana. It's the fastest growing. We had a lot of errors early on it, a lot of bugs. But recently, we've grown like 500% over the last 3 months because we fixed a lot of the issues that were on our RPC. And that's kind of why we got invited here to do the talk today. We do the mainnet, the devnet, archival support, and we focus on geo-distribution, and we're lowest latency in many emerging markets like Brazil, India, etc. So that's what we do. I'm going to talk a little bit about like Solana and what are some things we need to consider as a community here. So as you guys all know, Solana is really probably the fastest layer one out there right now. Current transactions per second are 3,300. Now, obviously, theoretically, Solana promises 60,000 transactions per second, but right now we're hovering around 3,300. So there's this kind of trade-off that we get when we, as a layer one blockchain, when we do these higher transactions per second. Ultimately, the node hardware needs to be better and have more resources in order to perform at that kind of level. So in many cases, you look at like other layer ones I compared to here. Binance Smart Chain started at 20 transactions per second. They forked Ethereum. Now it's grown to 200, give or take. It goes up and down a little bit. Ethereum is limited at 25. But these chains need a lot, those other chains need a lot less on the node infrastructure in order to run that. So as a community, we basically have a trade-off here. By having that higher transactions per second, we need a lot more resources on our servers in order to support that kind of high transactions per second. So there's like this whole debate that many of you are aware about right now over like how much decentralization do we need, should we have? But ultimately, there's some challenges that kind of come into this play because if the nodes are harder to run, they use more resources, right? They get a little bit more, less people are going to run them effectively. So like, Ethereum, you can run from a Raspberry Pi basically, right? You'll never run a Solana node on a Raspberry Pi, as many of you guys know here. So talking a little bit about that. So generally, Solana hardware needs about 7 times the hardware that like other EVM chains need, which introduces a lot of complexity. So last year, as Solana started booming, all the DeFi, the NFT summer, all of these kind of movements started really putting a lot of traffic and a load. And I think a lot of you remember the RPC issues that we saw as a space last summer in 2021. I mean, like a year ago last summer. And since then, it's gotten better, but there's a couple reasons it's gotten better. It's by no means perfect. So the first thing is that the Solana server program was really a game changer for this community. So I want to talk a little bit about that and recognize them because it was helpful for us and was helpful for other RPC providers. So effectively, because of the pandemic, there was a huge chip shortage, which still is somewhat in effect right now. But it was 2021, it was really, really bad. If you were trying to get a server that met Solana's specifications, you were looking at like a 6 to 8 month lead time minimum, right? So what the Solana Foundation did is they went out and they worked with all these different data center providers to make servers readily available to this community, right? So they went out, they signed long-term contracts, they worked on getting the right specifications, and then they made those available on a month-to-month basis to RPC providers like ourselves or individual developers, right? So I think that this single-handedly really changed the game, not just for Solana, but for many other different chains, because up until this point, a lot of the data center providers out there, even the cloud providers, were really, really skeptical of Web3 use cases because miners for a long time had really abused, server providers, right? So recently, you probably heard about, this happened a couple days ago, the whole situation with Hetzner banning like the validators, which they had long talked about doing, just not that many of us are paying attention to it. But that's really because they got abused from the Chia protocol on their disks, right? And so a lot of these providers were these bare metal server providers, these data center providers were very, very skeptical of working with any Web3 companies. But this program really made them pay attention to the size of the market for us, right? And so what I started seeing kind of after this program was launched, after Solana started getting these servers for the community, is all these other providers started coming into the market and building specific Web3 teams to address Solana and other chains as well. So it was really, really amazing opportunity. These are just some of the logos. I've talked to all these providers. We personally work with Latitude a lot. They're great. ZenLayer's VP told me that Web3 is the fastest growing for them. Same with Vulture. OVH now has a Web3 team. They're all trying to figure out how to support the needs of our ecosystem, which has been really amazing that they're giving that kind of focus, right? So let's talk a little bit about the hardware, and then I'm going to talk about optimizing software here in a bit. So if you're not familiar with these components, this is like a standard server. The Solana official documentation, you can see the official docs here. 16 core, 256 gigs of RAM, NVMe, 1 gig network, pretty common for a server. But that was really based on 18 months ago. And since then, the needs of the hardware to really optimize your node have increased dramatically, I'd say. And so now we're looking at an even bigger set of requirements. So I'm going to talk through these here. And give you guys advice, especially if you're trying to run a node, maybe work with an RPC provider. These are all things that you need to know. So generally, on the CPU, we see Intel and AMD are usually the most common options. We tested Intel early on. It does have the performance. It does work. But we saw dramatically better performance with the AMD third-gen CPUs. And it's not saying that Intel can't be better than that, but for the kind of the cost-performance trade-off, usually in our experience, AMD was really the way to go. The other thing is, too, the clock speed is very, very important. So I would not run Solana on anything less than 2.8 gigahertz. That's really a bare minimum. It needs to really be more like 4, to be honest, but you can run it at 2.8. And then the multi-core is very important. So if you're familiar with other chains, like EVM chains, they run mostly on single-threaded, but Solana does benefit from the multiple cores, the multi-threading. And then with the RAM, we started out at 256. You might be able to still boot a node at 256 gigs of RAM, but if you're doing any kind of high traffic, you're going to need up to 1 terabyte, right? So 512 is kind of the new minimum, and that's going to keep growing over time. So all these tests are done at 650 requests per second over not just one client IP, but hundreds, right? So that's kind of what it looks like for an RPC provider, or if you're building your own node to support this network. And then on the disk, you absolutely need NVMe storage. You need at least 2 drives. You could maybe get away with 1. We use 4 in RAID 0. I'll talk about in a second about why that's important. But the actual network stats, I just pulled these off our monitoring portal. receiving 200 megabits per second, sending up to 300 megabits per second, within that 1 gigabit per second recommendation there. So if you look at these requirements, the average person is really not going to be able to run one of these nodes in their home. And that's what we see on other chains, right? The decentralization, you can run, I wouldn't recommend it, but you could run an Ethereum validator right from your house. I know some people that do. I don't personally do that. But you really need to be running these kind of requirements in a professional data center or some cloud provider, right? And so that kind of, what we need to think about as a community is like, what things do we need to do to improve the decentralization? So if people are not able to run these in their homes, how can we work with managed service providers, data center providers, cloud providers, to really improve that decentralization to get more nodes on more networks in more places? All right, so to kind of go into the network side, where you host your Solana node matters a lot. In fact, a very lot. And there's a couple reasons for this. So as you guys know, blockchain is peer-to-peer technology. So the nodes, both the validators and the RPC nodes, are all talking to each other in the peer-to-peer protocol, right? And so because, as I mentioned here, you need that 1 gigabit per second kind of connectivity between to the network. That starts mattering a lot when you're using your node. All right. So if you think about it, a node that you operate needs to talk to a node that someone else operates through that system, and that receiving and sending of the bandwidth starts to factor into that. So what ends up happening here in the BGP and the layer 3 internet services is if you're next to a cluster of other Solana nodes, you get a lot of benefit from that. But if you're in kind of one of these edge markets, it's going to be really hard for you to stay at block height and for your node to perform, which, in my personal view, is a huge issue for our community, right? So here are some of the best locations. US East, we have like Virginia, Ashburn, Virginia. It's like the headquarters of the cloud. You got AWS there. You got Google Cloud, all the others, right? New York, Atlanta, all locations where nodes perform on Solana really, really well. West Coast is reasonable. Solana does a lot with Google Cloud. Google Cloud has a lot of regions over there too. Singapore, reasonable. Europe, reasonable. But as we start thinking about like bringing Solana to India, to South America, even to Southeast Asia, outside Singapore, it becomes very, very difficult to keep a node at block height. We are constantly trying to optimize the network between our nodes in those locations. But what we really need to do is just get more people running Solana nodes in those locations, which will ultimately improve the performance of the network and the distribution of the network. So it will help your node out too, but it will also help us, just as a general community for that decentralization and that distribution. So one of the things that my customers ask me all the time, and you guys probably have the same question, is why is Solana more expensive than, say, Ethereum or some other network? So here are some of the challenges we face as a node provider in this space. So there's such little documentation on best practices. We've been lucky to kind of share information in forums like this with other providers like Triton One and others. But most of what has been learned, I think, from my understanding, is just in like tribal knowledge. It's trial and error that people have done. It's not documented on the Discord or the official documentation. So what we can do is we can start documenting this stuff on the community spaces to do better and to share knowledge. Also, the hardware keeps increasing, like I said. Best practices, server specs, I think like we don't have a lot of information on that. There's also issues. Solana, for its archive data, for its historical data, the Solana Foundation uses Google Bigtable, which is great, but there's some issues with connecting to that. We fix this. I'm going to provide you to a link to a pull request where you can get our code to do that. It's very simple. Every time Solana has had outages, as we've all been aware, that comes back to the node providers. We have to recover those nodes very quickly, which is hard. And sometimes in some instances, our historical data has blocks missing when that happens, and we have to go and manually backfill those, right? As I already talked to you about, the geo-distribution of peering issues comes in, and that plays a fact. And then the updates are frequent, which is awesome. Love that we have a lot of updates, but we have to stagger them because the nodes take a long time to restart. So it uses more DevOps resources. So for all those reasons, Solana, we have to end up passing that cost off to our customers in order to at least break even or make money on a chain like Solana. So I want to talk a little bit about like the cost of supporting archive data, the rough cost. So to run a Bigtable instance with any kind of meaningful traffic volume, it's really going to cost you about $8,000 per month that you're going to be paying to Google Cloud to do that. Just in comparison to other chains, with Ethereum, Go Ethereum, under $1,000, you could run a server that has every block indexed right there. With Aragon, less than $250. Something you might not know if you're not in the EVM space is that there's multiple node clients, right, for Ethereum, and some perform better, others for different things, right? So Aragon is like a rising star in the community and does really, really well with handling that archive data. So I think there's more solutions we could do as a community, in this space. Now to talk about some of the principles of optimal performance on the software side. We've already covered network and hardware. Solana tends to be, from the node perspective, generally stable. But what ends up happening is because of the speed of the chain, if you're trying to bring nodes to block height, they really can't be receiving traffic while doing so. So it's very difficult. It's very hard to bring a node all the way to block height so it's usable while it's also serving any kind of traffic. Of course, it could, there's many types of requests that can be still served while not at block height. But you need to turn off traffic when that node is recovering. And so this can be done with a very simple script. If the node isn't at block height, stop sending traffic to it, let it recover, test the block height again, and then resume sending traffic. That is what you're going to need to do to really serve traffic. And then as I spoke to you earlier about having 4 NVMe disks in RAID 0, if you can have a bigger drive on your node, you will definitely not need to make as many archiver calls, those that kind of expensive archiver calls to Google Bigtable, which helps out a lot. So a general rule is 1 million slots, 750 gigabytes of disk space. So we personally, on our local nodes, use like 6 or 7 terabytes of data just on our Solana nodes. So we don't have to always be going to the archive nodes or the archive service to do that. So I want to have a few minutes for Q&A. So where do we go from here? How do we get better as a community at supporting our nodes? And I think a lot of these principles still apply to the validator community, not just the RPC community, because we get better node clients, we get better performance, especially on the hardware side. That does impact our validators too. One of the things, or one of the concepts that has been really, really valuable in the Aragon node client is the RPC daemon, or a daemon. It runs separately from all the peer-to-peer processes. And we've seen really good performance off that. I don't think that's implemented in the Solana node client as far as I can see, but we think it would really help if we could get there as a node client. So that's my recommendation to the Solana team to do that. And we also need to start seeing alternatives to Bigtable. So right now, if you want archive data, the only option is to use Bigtable. I actually love Bigtable, but it's using 80 terabytes, which is costing us $8,000 a month. And we'd love to be able to run that locally, without having to query Bigtable. And so I think getting the support from the Solana Foundation on both those things would be very helpful to node providers, very helpful to our community. And then, think about it, one of the things we've been working on with other chains, specifically with Binance Chain and a few others, Polygon, Avalanche, is this whole concept of side chains. So, as we continually scale Solana, we're already really at the hardware limits at 3,300 transactions per second. So as we grow as a community, as more people come into the ecosystem, that is only going to go higher. How do we keep scaling with that effectively? We might want to start thinking about, offloading some of that traffic to a Solana sidechain. And that's just a recommendation. I think, future focus, for the future Solana roadmap that we might start wanting to look like as a community. Okay, so. So one of the things, if you run a node and you can't, if your connection to Bigtable drops, you can go to the GitHub for Solana Labs, go to pull request 26217, and we have a fix. It's just a simple one-line code fix that will help you. It has not been merged yet into the official repo, but you guys can use that if you want to get better performance on that, that archive service. So that's what I wanted to talk to you about. We're excited to keep supporting developers in the Solana ecosystem and beyond, but I'd love to leave it up for Q&A. If anyone has any questions about the RPC service around performance, please come up and ask a question. I think you have to go to the mic.
Hey, thanks for all the insights. So do you guys publish performance data of your nodes, like a graph over time, how many slots you're behind or ahead of the rest of the chain?
We have it internally. We're working on an external tool that's going to make it, it's an open source monitoring service for nodes that we're going to publish to the community. So it's not available yet, but we do collect that internally. So, it is a hard chain to keep up with, but
it's just we've been trying, all the guys out there, QuickNode, Alchemy, Genesis Go, and it's kind of crazy. They're always running behind, and then our apps are like flip-flopping, old state, new state, and stuff like that, right?
Yeah. Yeah, like I said, there's a lot of issues that, as node providers, we're all dealing with. So I think the recommendations here can help us get better as a community. But yeah, we can absolutely publish that, and we have a tool to do so. Yeah.
That'd be awesome.
Awesome. Oh, sorry?
How do you measure the latency of your RPC nodes, and how do you publish, like how behind are you in processing those blocks through the RPC call?
Sorry, really hard to hear you.
Okay. How do you measure the latency of your RPC service?
Yeah. So we do measure our latency of our RPC service. What we do is we do a combination of different calls, both like stuff that regular node and the archive service will do. And we use little monitoring networks from like Google Cloud. We have like little scripts running in DigitalOcean, AWS. And then we just look at like the latency across all of our user and client data as well. And we have a formula for pulling that together to show it. So keep in mind that when you look at a Solana latency RPC, that is testing the latency from a point A, right? Which might be, if you're running like, I don't know, like you really want some neutral data on that, because it would be very easy to skew that data if the RPC provider is running the test in their own data center or something like that. So you really need some beyond like 1 point to test the latency.
Yeah, thank you for that clarification. I do have a follow-up question.
Okay.
I mean, from the moment a block was produced and the moment that that block was usable by an RPC server, how do you measure that latency?
Yeah, we have a tool for doing that, but we also have an enterprise service that we do where we have a special focus on exactly that, on making sure the accurate data is relevant to those users and most up to date. Yeah, okay. One more question. I think I'm going to get chased off the stage.
Yes, thanks first of all for this presentation, and I really appreciate that you were emphasizing the problem of decentralization. And I would like to have like a sense of the future that you can imagine. For example, you were like saying that we can use side chains like afterwards, but could it be like possible in the future like if there is like a problem of decentralization, that to lower down like the requirement for like running a node, so that I can run a node at home, for example? Is that possible to imagine or not?
It would require. So the question is like, what is the future of a potential sidechain? So one of the things we've been working on with Polygon is the supernets, Avalanche with the subnets, and then Binance application sidechains, which we were the majority contributor to. So really what the concept of sidechains is we might say NFTs are going to be broken off into their own sidechain, gaming traffic broken off into its own sidechain, and then those sidechains will have a set of hardware that can run those. So what we would want to look at is, can we bring down the hardware requirements on the sidechains, and that would really help us with that decentralized effort.
And on the main chain, is that possible?
I'm sorry?
On the main chain, like on the...
It's going to be hard. I think a lot of re-architecture, but probably not for the foreseeable future. All right. Thank you all so much. Enjoy the conference.